Engineering notation. Engineers use a form of scientific notation known as engineering notation. In engineering notation, the power of 10 must be a multiple of 3. A number written in engineering notation is expressed as the product of a number between 1 and 1,000 and a power of 10 whose exponent is divisible by 3. So this is different from scientific notation. Scientific notation was a number greater than or equal to 1, less than 10. And there wasn't the restriction on the power of 10 that we have here with engineering notation. Converting standard notation to engineering notation. To convert a number in standard notation to engineering notation, we would move the decimal in groups of 3 until we get a number greater than or equal to 1 and less than 1,000. If we move the decimal left, we are multiplying by multiples of 10, which means the resulting exponent will be positive. Example 1. Convert 48,500 to engineering notation. To do this, we need to get a number that is less than 1,000 and greater than or equal to 1, so we need to move the decimal left. We will move the decimal in groups of 3 since the exponent has to be a multiple of 3 for engineering notation. So first we'll move 3 places left, and we then see that we get a number, 48.5, that is, yes, greater than or equal to 1 and less than 1,000. So 48.5 will be our number part times the power of 10 with exponent 3 because we moved left 3 places. Hence, 48,500 is equivalent to 48.5 times 10 to the third, the engineering notation of the number. If we move the decimal right, we are dividing by multiples of 10, which means the resulting exponent will be negative. So here's an example where we are going to move the decimal right. If we have this very small decimal number and we want to convert it to engineering notation, we need to move in groups of 3 to a number that is going to be greater than or equal to 1, less than 1,000. So here's 3, 6, 9, 3 more, we get to 12. So if we move to the other side of 2, we will move 12 places to the right, and we get the decimal number 2.045. Multiply it by the multiple of 10 with exponent 12 because we moved 12 places, and negative because we moved to the right. So this is now a number in engineering notation because we have a number between 1 and 1,000 and a power of 10 with an exponent that's divisible by 3. Converting engineering notation to standard notation. Converting from engineering notation to standard notation is done the same way as converting from scientific notation to standard notation. If the engineering notation has a positive exponent, it will convert to a big number in standard notation. If the engineering notation has a negative exponent, it will convert to a small number in standard notation. We want to convert this number into standard notation, this number that's in engineering notation. We'll move the decimal 6 places to the right to get a big number. Since the exponent is 6, this is a typo. This should be 406. So we have 406, and then we add 6 zeros because we have to move the decimal 6 places for this exponent of 6. So then we get this very large number, which should be 406,000,000. A large number because the exponent was positive. Multiplying numbers in engineering notation. Multiplying numbers in engineering notation is the same as multiplying numbers in scientific notation. When we multiply numbers in engineering notation, we multiply the number parts and then we add the exponents. So here are 2 numbers in engineering notation that we're going to multiply. First, we'll multiply the number parts, 26.4 times 722, to get this very large number. Then we'll multiply these power of 10s, applying this exponent rule where we add the exponents to get 10 to the 9 because 6 plus 3 is 9. And so now we have this number times 10 to the 9, which if we want the answer to be engineering notation, we still have to move this decimal because this number is much greater than 1,000. So if we move the decimal in a group of 3, so over 3 places, then we get 19.0608, which is a number between 1 and 1,000. And since we moved 3 places to the left, we'll add 3 to our exponent to get 12, which is indeed divisible by 3. So now we have an answer in engineering notation. Remark, if we had moved the decimal right 3 places, we would have added -3 to our exponent. So if we had gone to the right instead of left, we would have had -3 and ended up with 6 as the exponent. But we would have had a number that was way too large for engineering notation, since it wouldn't have been between 1 and 1,000. So the correct thing to do was to move left. Dividing numbers in engineering notation. Dividing numbers in engineering notation is the same as dividing numbers in scientific notation. Dividing numbers in engineering notation. Divide the number parts and subtract the exponents. So here we have 2 numbers in engineering notation. We'll divide the 2 number parts, 12.75 by 236, to get this small decimal number. Then we'll divide the powers of 10, subtracting the exponents. Be careful because you have -15 minus -9. -15 minus -9 is -15 plus 9, which is then -6. So here we have a power of 10 with an exponent that's divisible by 3, which is what we want for engineering notation, but the number part is too small. It needs to be between 1 and 1,000. So we'll move our decimal. We don't want to go left because that'll just make it even smaller. We need to be greater than 1. So let's move our decimal 3 to the right. If we add 3 more to 6, we'll still get a number that's divisible by 3. So let's move 3 to the right. This gives us 54.0, which is a number between 1 and 1,000. That's what we want. And since we are moving to the right, we're going to add -3 to -6, getting -9. If we had gone left, it would have been +3, but we moved right, so it's -3. So ultimately, we get 54.0 times 10 to the -9, which is a number in engineering notation. Powers of numbers in engineering notation. Raise the number part to the power and multiply the exponent and the power. Okay, so here is a number in engineering notation raised to a power. We'll raise the number part 15.4 to that power, so we'll square it since the power is 2 to get this number. And then we'll take the power of 10 and raise it to the power, multiplying the power of 10 times this power, the exponent of 10 times the power, to get 10 to the 18. So now we have this number times 10 to the 18. And this is a number already in engineering notation, so we're done at this point, right? We've got a number between 1 and 1,000, an exponent divisible by 3. So we are done.